You can think about it and let me know when you're able to join at midnight. So digital logic design. We are designing digital systems, right? Now, we first of all need to understand what digital is and what analog is, because these are two opposing terms. What when we say digital, what do we actually mean? Hey, media me make up sound to me bana me kwana me be kasa o. Masa, suban ye nti ase o ha o. We all have to talk. Masa. Let me go through and pick someone. Kelvin, Kelvin, yes. If you don't talk, that means that you've just joined and you are not really online. The whole patch means that when you have to chime me, that's how I'll take it.
Yeah, please, I'm here.
Yes, Kelvin. So what's the meaning of digital? When we say digital, it's saying. And Kelvin, are you telling me that from level 100 to now you don't know what digital is? Hey. Kelvin. Okay.
Sir. Yeah.
Uh-huh.
So it's the use of technology systems.
Okay.
Sir. And processes that create, store, and process data.
Hey, we'll be kind near my mommy. You, my fan is I'll take it like that. Somebody's reading styles for me. I'll just take it like that. So we have Bisabella. Isabella. Is it Isabella or Bisabella? Okay. That's how you spelled your name, Bisabella. Bisabella, please unmute your mic and talk. Bisabella, where you do? Oh, what to phone not to baby? So she have just put the phone somewhere. She's just somewhere. Hi. She's now walking to her phone to unmute. Isabella, please walk quickly to your phone. We are waiting for you. Right now, you are the woman of the moment. Yeah, she's laughing behind there. Yeah. Okay, no problem. I'll meet you in class. That means she's not even with her phone. Celestine. Yes, I see Celestine. Celestine. Oh, Celestine is leaving the call. Okay. Then we have, yes, Hanania. Okay, Hanania, save the class. And yes, I'm on Mugwase. You're grazing yourself this morning. All of you.
Good morning. Good morning, sir.
Yeah. Good morning, Hanania.
So talking about digital and analog.
Yes.
Yes, sir.
So actually, digital means in terms of data, it's like representing data in a discrete, discontinuous form. And analog is like continuous physical wave, something like that.
Discrete, discontinuous form. Wow. I love those two terms. But the reason why I'm not happy is because you seem to have the babana as a so you're just pouring the baba that you've ate. Maybe Celestine will give me a better. Celestine, yes, Celestine. I see your hands up. Let's talk. Celestine, kindly save your class. What is in? He's in the chambers of disgrace. Hanania has done well. Yeah, it's good. I think we can clap hands for him. But Celestine, please unmute and then let's hear your submission.
I think digital is the use of zeros and ones to deliver messages and send signals.
Awesome, that was good. Digital uses zeros and one. Yeah, that's good. Okay, so I think you all know digital, so I'm not going to explain it. Say you are waiting for me to explain me. Maybe Bisa, you didn't mind me, so me too, I won't mind you. So before I would answer, I would have to remove all the people that didn't talk. I'll start from Bisabella. She didn't even mind me. So I'll remove all of them. Then the three people that talk, I'll just explain it to them. I hope that is fair, isn't it? You do me, I do you. Man no go. Then where you're doing. Okay. Anyway, so you guys are not wrong. In fact, I really like your contributions, especially what Hanania said. Hanania said was very right, and what Celestine said. When we say digital, I wouldn't explain it from digital. I'll start from analog. You see, let me put it this way. If we have a thermometer, all of you are science students, right? So we have a thermometer like this, a mercury in glass thermometer. I remember how in junior high school they asked us to draw this thing. Oh, Charlie. This is the only use we are going to use it for. So don't worry. What you learned is not in vain. So let's say that the thermometer is at 10 degrees Celsius. Can it ever happen that the thermometer will suddenly jump to 35 degrees Celsius without going through 15 degrees Celsius? Maybe there is a magical thermometer. Can it happen that way?
No, sir.
No, great. It can never happen that way, right? So that is the analog thermometer. Analog thermometer. Now, let's look at a digital alternative. In a digital alternative, can we say that in digital thermometers, when the temperature reading is changing from, let's say, 15.7 to 30.5, can we say that it changes through all the temperature points between 15.7 and 30.5? Can we say that for the digital thermometer? Okay, so you're confused. Let me ask it this way. When you take the digital thermometer, you can see that, for instance, the temperature will be 13.20. The next increase in temperature, the immediate next, the smallest increase it can recognize will be 13. Will be 13.30, right? The next will be 13 point what? 40, 13.50 point until it gets to 30 point what? 50. Now, can we say that for a digital thermometer, the temperature changes rises through every single number between 13.20 and 30.50? Can we say that for a digital thermometer?
No, sir.
Can we say that for a digital thermometer?
Yes, sir.
So
No, sir.
hello? Someone was saying something. I didn't hear. So I'm asking that, can we say that for an analog thermometer, if temperature is rising from 10 degrees Celsius to 35, it changes through all the ranks, through all the ranks. It goes through 10 degrees Celsius, then it gets to 10.000001 before it moves to 10.05, before it goes to 11, then it goes to 11.555556, all the billion numbers until it gets to 35. That is how it works for the analog. Is that right? Is it the same way that the digital system for the digital
No.
thermometer? No,
No.
No, sir.
not at all. It doesn't, right? Now, how does a digital thermometer works? It rises through discrete, right? It rises through discrete counts or discrete number of changes before it gets to, 30.5. So let's say, for instance, in the analog world, I can say that how many numbers exist between 0 and 1? How many numbers exist between 0 and 1? Can you count them?
No, sir.
Oh, like between just 0 and 1 person, what do you mean can?
No, there are many.
You can't
No.
count.
Are you really sure you can count? But say it's just 0 and 1.
You can count.
Great, you
Yeah,
can
that's
count.
all.
Great. So you can't count the numbers between 0 and 1 because they are so infinite. They are so uncountable. Is that right? And they are continuous. They continue forever and continue to infinity. So one word that defines the analog world is continuous and infinite. Infinite. The word is just one. When we talk about analog, the word that comes to mind is infinite. Infinite. Is that right? Now, so the analog world is infinite, is uncountable, and is continuous. Continuous in the case that mercury rises through from 10 degrees Celsius to 35 degrees Celsius and it goes through every single point that exists between both of them. Right. So it's infinite and it's continuous. Okay. But in the data world, so let's say that we want to store all the numbers between 0 and 1 on a hard disk. Please, can we get enough storage to store it?
No.
Okay. We can't get enough storage to store it. We can't get enough storage to store it because it's so infinite. Like all the storage in the world put together can't store all the numbers between 0 and 1. Is that right? Then the question is it really important for us to really store all the numbers between 0 and 1? Is it really, really important? Do we really need to store all the
No,
numbers
sir.
between 0 and 1? We don't. We don't. We really don't need
No.
to store all the numbers between 0 and 1. That means that if we really want to store numbers in a range between zeros and 1, what we can actually do would be to find a certain representative number of numbers, right? We can just use something to represent something, right? So in the analog world, I can take Celestine in the whole class. Celestine is the only one I know. I don't know any other one. So I can take Celestine and I'll say, okay, Celestine, I want to store Celestine in a computer. Can I take her as she is and just put her in the computer? You see, that's not possible, right? So the real world and everything in the real world lives in the analog realm. Now, everything on the computer, right, lives in the digital realm. So we can say that the digital realm is an approximation of the real world where we use countable. The other word for countable is what? Discrete. Right? So we pick a countable size to what represents the real world. So in the digital world, we are living in an ideal world. in a digital world. So the digital world is an ideal world. Please, are you in the class or you've gone home to sleep? Some of you have gone back to bed. So the digital world is the ideal world or the summarized world. Summarize. Then the analog world is the real world. Feeling, the very real world. Please, we understand. One other word we can use to describe the digital world is the opposite of continuous, which is what? Discontinuous. Discontinuous. Okay. So the digital world is an approximation of the analog world, right? Whereby we use countable, which we call discrete, right? Countable number of samples to approximate, the analog world. Please, do we understand?
Yes, sir.
Yes, sir.
Okay, so we can have for instance, the network is very slow, so there are some delays before you see my screen. Okay. Okay, so when we look at this is how a temperature looks like, right? This is how a temperature curve looks like. The network is very slow, so it's not updating on your screen. So we can see that a temperature looks like a curve. Okay, it looks like this curve. And that's the analog world. It captures all the fine, infinite details between 2 points, right? All the fine, infinite details is all captured. Now, so that's the analog representation of temperature. Now, in the digital alternative, right? In the digital alternative, you see that the temperature will not be that fine. It will be discontinuous. Trying to use something to represent something. We just take samples. Then we'll say, okay, that's how the temperature looks like. So we can take 1 second. And we say, 1 second, okay, 1 minute. So we can take 1 minute and we say, every 1 second, let's go and measure the temperature and see what it is. Let's measure. So that at least we can form an understanding of how the temperature changes look like. So that is an approximation of the real world or the analog world. Please, do we understand?
Yes, sir.
Yes, sir.
Okay, great.
Yes,
Now, if the analog world is actually the real world that has everything in the world, it represents the world as it is. If that is what the analog world is, then why are we struggling hard and wasting our time? I would say wasting our time to summarize the real world in an approximate form. Because right now the world is a digital world. We've moved away from the analog world to the digital world. So why are we using a representation of the real world and we are now relying more on the digital world instead of using the analog world? Meanwhile, the digital world is just a sample, a very, very limited sample of the real world. Why are we doing that? Yes. Hanania.
Yes, sir.
Talk. One I don't want about me. I didn't ask you to let me know you. Now that I've known you, I would day on you, sir.
I said so.
So
The
someone is
idea I have is that Since it's not possible to have all the data for the analog, right? Taking the samples, after taking the samples, you'll be able to approximate to get the real world data that you want.
Okay, I think you are not very wrong. What you're saying is very correct. So you're right. Thank you very much for your suggestion. Now, without really thinking too hard, let me just ask you this question. Assuming you want to store all the numbers between 0 and 1, we've already established that it's not possible, right? So that means that, number one, the analog world is not even storable, at least not yet. Right now, with the technologies we have, there is no way you can store the analog world. Please, do we all agree?
Yes.
Yes, sir.
The way you
That's
are slow in answering the question, that means that you don't agree.
Yeah, we agree.
You agree? So the reasons
sir.
why we are moving from analog to digital. So the first reason, what will be the first reason? Yes, who can just brainstorm and tell me what the first reason is? Reason number one is what? So that we can what? Store for storage. Because the analog world is not storable. The analog world in its raw form is not storable. Please, do you understand? So we are moving away from analog to digital because of storage. Number one, I want to store. Number two, why are we moving away to digital? Number two, we are moving to digital because, the radio device, the radio that we use at home is predominantly an analog device. Have you observed that when we transmit sound through the radio, those of you that usually go to the village, you hear the sound coming and it's doing tone. There is noise in it, right? Good. So the analog world is very sensitive to noise. So we say noise sensitivity. Very, very sensitive to noise. Example, the radio, the analog radio. With the analog radio, you can see we have a lot of analog radio. We have a lot of, static noise. Then we have a lot of cracking and distortions, right? Cracking and distortions. Unfortunately, I don't give my slides to my students. The slide I'll give you is not something you can really use to prepare for the exams. So you have to make your own notes. You see me, Graham, writing. If I had PowerPoint, I'll have just been showing it. I don't even have PowerPoint for this. I have written my own note. So you need to write your own note. Then, yes, Uber be seeing summary. I betray me exams. Like how? So the next point is that the next reason is that there is signal degradation. You see, those times when we had the cassette tapes and the Warren's CD, compact discs around, and these storage devices we have, you can record your voice on a cassette tape, and then after some time you go and play back now, paper, and then it's gone. Right? So signals degraded over time. So we have signal degradation. So it wasn't really reliable. Right? Then when, let's say you are, those times where we had the telephone and voices were just sent in the analog world, someone would just call take a phone and call them. There is no encoding, there was no digital world. So your audio signals now the same thing that is sent through the cable to the other end. Or imagine that the internet was analog. Then you are sending a text message to your friend. And because of resistive losses, some of the voltage signals were not seen. So some of the signals were corrupted. How will you be able to know if there is an error if you don't have a digital system? There is no way you know because you didn't store it. You didn't have a backup version. So you won't know. You can't compare both of them and see if there is an error or there is no error. Right? So it was difficult to detect error. Error detection and correction. Right? Then the fifth thing is that analog world is very, 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 very rigid. Very, very rigid. You can't easily program it. Let's take the radio device, for instance, or the television. The analog television we had at home. It is fixed for one thing, which is just watching the channels that has come with it. And that's all. You can't use it for any other thing. But right now, with the advent of digital electronics, we can have computers and laptops. And with our laptops, we can reprogram it. If the laptop comes and then there is no TV on it, you can sit down and write a TV app and it will be playing TV for you. If the laptop comes and there is no music on it, you can write a music app. You can't do that to a television. Even though a television has speakers, you can't program a television to play music unless they have originally programmed it to play music. Please, do you understand?
Yes, sir.
Yes,
Great.
Yes,
So
sir.
you
sir.
see that the analog world was very, 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 very limited. You couldn't easily program it. Right. So because of these five reasons, and there are many other reasons, I just wrote five for you. The rest is for you to find out if you really want. In the exams, I'll just ask you to write three or four. That one in the exams, I'll ask you to explain. Right. So, that means that we really needed to move to a digital world where we will store things. Now, recall that I said one word really defines the digital world. And what is that word? Yes, one word. One word for the digital world. And what's that word? Who remembers? Hanania.
Discrete.
Discrete.
Sorry.
Disc discrete. The word is discrete. Now when you say discrete, discrete means countable. Nana Kojo. Yes, you have a question.
Okay.
Your
I
hands is up.
was, I
That's
was, yeah, I was answering the question, but
okay.
Hanania has answered it too.
So next time the question will come for you. I've reserved the question for you.
Oh, I'm okay, sir.
Oh no, please, you can't be okay like that. How? Question way there, oh dear. Okay, so yes, so that's just by the way, don't mind me. So discrete, right? So one word that defines the digital world is discrete. Okay. Now, when we say that um, the world is digital, that means it uses discrete countable, something you can count, like countable systems. The problem is that we are counting. If we are counting, what are we counting in? So, there are several number basis systems. So, what base are we counting in? Are we counting in? Right? What base? What base can we really use to represent the world and capture the world and store our data and information? How can we encode
Base 2.
the world into some kind of a form we would store? So someone said base 2. So Kojo, why base 2? Kojo, your parcel has arrived. Now why base 2?
Say no idea.
No problem, Kojo. Well done. No idea is still a very good idea. Now, who said base 2? Please now explain why. Yes, kudos. You said base 2. Why base 2? Yes, kudos. Why base 2? Kudos. I think now Google or AI more. Okay. Matthias, you are now going to look at ChatGPT and come and tell me. Let's continue. So we are using base 2, and we are not going to use base 10 or any other base because think about it. If you want to store a number in base 10, how? Like, you, how will you be able to technically do this? Like, how? It just doesn't make sense. You can't really think about it. But let's take a certain number. Let's take any number. Any number like Celestine's age. So Celestine's age is, 11 years old. Okay, Celestine is 11 years old. Okay, so Celestine is 11 years old. Let's take Celestine's age, which is 11 years old. And let's try and see if we can convert it to base 2. Right. Okay, Celestine. So Celestine, we are converting your age 11 years to base 2. Okay, so this one you have to do it for us.
How you see? I don't know what Mike is so yeah. Why did
Biscuited, you are wanted. Leocata.